Welcome students. Today we are going to discuss electrostatics from plus 2 physics. If you consider Neet exam or JEE mains level exam, definitely 2 to 3 questions will be coming from this chapter. Especially Neet exam it is. And in total electrostatics they have divided into two main parts, that is forces, fields, flux, dipoles. Okay, all this should be discussed in part 1. And second part is going to be potentials, potential energies, capacitors, how to combine, like how to take the combination of capacitors and all everything in the part 2. Okay, part 1 and part 2 together, sometimes they may ask you 4 questions and sometimes 3 to 2 questions also, definitely. So if I classify the electrostatics, the chapter it is part 1, where 2 questions we can expect, that is force, field, flux, dipole, force due to, a field due to dipole, monopole, like spherical charge distributions, linear charge distributions, surface charge distributions, everything. Okay, and coming to the second part, from where we can expect 2 questions again, that is part 2, potentials, and potential energy, capacitors. Okay, and we can say directly this is the scalars, all are scalars, and these are vectors, right? So first we are going to discuss this part and then we'll go for this. Okay, and problems based on the first part we'll discuss today and then we'll go for the second. Okay, so let us go to the problem number 1. This is the problem which is asked in the Neet 2019, which is based on simple Coulomb's law. The force between 2 point charges is given by Coulomb's law, which is equals to 1 by 4 pi epsilon naught into Q1 Q2 by R square, right? So according to this, we can say the force is proportional to the product of the 2 charges. Okay, so it is not any other operation. Okay, just is the product of the 2 charges, neither addition nor subtraction and also division, right? So based on this, the problem has been asked here. Okay, in the Neet 2019, is very simple and straightforward. There are 2 charges which are equal in magnitude but opposite in nature, that is plus q and minus q. They are placed at a certain distance, smaller meters away. Now the force between them is 1 by 4 pi epsilon naught into q divided by r square. Notice here I am not taking the sign between the 2 charges because while calculating the magnitude, sign is not required. The sign is regarding the direction only. Okay, and we all know that unlike charges will always attract each other, like charges will always repel each other. So the force between these 2 charges must be, it is attractive in nature. Okay, so minus sign indicates that attractive in nature. So only we are not having here minus sign because we are just calculating the magnitude, right? So don't you get confused because I am not taking the magnitude here. Now what they are doing in the problem, just 25% of the charge is has been given to the other charge. Say from plus q, 25% has been removed. If you remove 25%, then how much percentage it remains again? 75%. In fractions it is 3/4. Okay, and you are giving to the minus q. We are algebraically adding this, okay, but they are going to be subtracted because of the negative nature of the second charge. So this will become minus 3/4 of the total charge. Clear? Then again, of course, they are separated by the same distance. Then the force, new force between them, F prime equals to 1 by 4 pi epsilon naught into 3/4 of q square. right? And here also I am not taking the negative sign which is present here, okay, because of the fact that negative sign indicates just attractive in nature, okay, so direction only. So we are calculating magnitude, so we are not taking the negative here. So definitely f prime, you can say 9 by 16 times the f, which is matching with one of your 4 options, typically the third option. Okay, and for this they are giving you 4 marks. It's very simple and straightforward solution. Remember, the Coulombic force is proportional to the product of the two charges, not the addition, subtraction or division. Just like the gravitational force, okay, gravitational force also proportional to the product of the masses of two objects, okay. So just like this, just like Newton's law of gravity it is, right? So let us go to the next problem. I hope you got it. Next, a charge Q is placed at the center of the line joining two equal charges capital Q. The system of three charges will be in equilibrium if small q is equals to. So there is a small q we are placing in between the two equal and opposite charges. Equal, they didn't mention opposite, okay, I'm sorry. So just equal charges only they have mentioned. So by default we should take like charges, right? Say capital Q and capital Q, there are two charges which are separated by r meters, okay. Did they mention distance? Nothing mentioned, okay. So r is the distance, let it be r, okay. Now we are placing a small q charge somewhere, sorry, not like somewhere, okay, they have mentioned clearly here that is at the center, okay. So at r by 2 we are placing, this is a small q, that means this is r by 2, this is also r by 2. By placing this small q at the center, our intention is to bring the system into the equilibrium. What is equilibrium first of all? What is equilibrium? Equilibrium stands for the net force acting on the system should be 0. Okay, net force acting on the system. I am talking about the system. System stands for there are two charges. Okay, and with the third charge we are introducing, there will be total 3 charges. So system stands for the total 3 charges. Did you understand? So if the net force acting on the system 0, it indicates, or we have to understand it as the net force acting on each and every charge of the system must be 0. That means net force acting on the charge, like first charge here and second charge here, the third charge we are placing here, okay. The net force acting on the first charge, second charge and also third charge must be equals to 0, right? Then only the system will be in equilibrium, right? So let us calculate the value of small q. We can find the value of small q by equating the net force acting on any one of the given charges to 0, okay. So force on q is 0. The meaning is, if you can draw the diagram like for second charge, so the force due to the first q will be this way because they are like charges, that is k q by r square. The force due to the third charge that we are placing at the center is again we have to consider this way, that is k q into capital Q by r by 2 square. The sum of these two forces is the net force and it should be 0. Okay, why it should be 0? Because that's a definition of equilibrium I have given already here. It's a definition of equilibrium. So if you equate it to 0, trust me, you will get the kq by r square, that side 0. So capital Q plus 4 small q capital Q, sorry, not capital Q, yeah, 4 times small q equals to 0. Then small q equals to minus q by 4. That means if you place 1/4 of the capital Q charge and that too negative charge, like unlike charge, you have to place. Okay. The minus indicates if capital Q's are positive charges, then the small q must be negative. Suppose if the capital Q's are negative charges, then the small q should be positive. That is what the minus indicates. The minus simply indicates that it is unlike. Okay, and it is 1/4 of that. So this is based on equilibrium. It has been asked in Neet 2013. Okay, regarding this, the shortcut I can tell you in the next video. And the fourth problem, which is 1994, somehow long back it is. So the problem is regarding the fields and field lines. Okay, so sorry, field line it is. Okay, so what is field line? Let me explain here. It is a hypothetical line What is hypothetical? First of all, hypothetical is something which we are imagining. It is not really existing. Okay, to explain the properties of field, we have to assume these lines. Okay, that is how the scientist has done, and we have to follow them. So it is a hypothetical line. The tangent of this line will give you the direction of the electric field at the point where you are drawing the tangent. For example, there is a field line which is like this, and here you need to find the direction. Then you have to draw the tangent this way. Okay, so this is electric field direction at this point A. Say if you are finding the field line direction here, say at this point B, then you have to take the tangent this way, right? So this is electric field, say this is E1 and this is E2. From point to point, magnitude and direction may change. I hope you got the clarity. Wherever you want to find the direction of the direction of the electric field, you have to draw one tangent at that point. Along the tangent, the field will be. Understand? Remember, there should not be intersection of two field lines. I mean, there are no two field lines which can intersect each other. If they are doing so, they are violating the properties of vectors. Okay, and next thing, the electric field lines are diverging lines if it is positive charge, converging lines if it is negative charge. Okay, so for example, the field lines I have drawn here, there are four field lines like this. They are diverging field lines. So necessarily, according to our convenience, we have taken we means not we both, okay, the scientists, right? So according to our convenience, they have given the diverging field lines stands for positive charge, they have mentioned, and if it is converging field lines, it is negative charge. Okay, I hope you got it. So converging stands for negative, diverging stands for positive. Now in the problem, all the field lines are converging only. See this. The two charges are Q1 and Q2. For both of them, the field lines are converging, right? So see the arrows, okay? By seeing the arrows only, you have to decide whether they are converging or diverging. So you can see the arrows and decide they are converging. So definitely this is negative charge and also this is negative charge. And how to decide the magnitude of the charge? Remember, the magnitude stands for the number of field lines. Magnitude stands for the number of field lines. The number of field lines. Meaning, here you can count manually 1, 2, 3, 4, 5, 6, 7. Okay, here 7 field lines are present. And here also 1, 2, 3, 4, 5, 6 and 7. So there are 7 again here. So equal number of field lines. So definitely the Q1 and Q2 must be equal. I hope you got it. Equal number of field lines in the problem. So Q1 and Q2 are equal. So we can say option A is what? Q1 is positive but Q2 is negative. It's the wrong option because both are unlike charges. Both are like charges and they necessarily negative charges. Okay, Q1 is negative, Q2 positive, also wrong. Both are negative is correct. Okay, option C will be correct. This one. It's very simple and straightforward problem, and this will give you 4 marks. I hope you got it. And next, the problem, it is asked in 2010. It is regarding the flux. Right? The flux is nothing but, mathematically the flux is the field line, the electric field dot area, dot product. Okay, mathematically it is electric field and area. So how to calculate it? It's very simple. If you expand the dot product of two vectors, you know that EA cos theta. What is theta? The angle between field line and area. Okay, the projection again here. Okay, area means not the whole area, total area. It is a projection of the body. Like for example, a sphere you take. The sphere is the shadow of the sphere is considered on the wall. Definitely, it's a circle, right? Circle of radius smaller. So definitely the area will be pi r square. So you should not consider the whole area. You should consider the projection of area only, depending on the situation here. Okay, again. So, but how to consider the theta is very important here. Listen, the theta is the angle between. Theta is a angle between, you know, the field line, that is a normal drawn, we can say normal drawn, otherwise let me define it. Angle between field line, and normal drawn at, not at, okay, to the surface, you can say. How to visualize this? Let us consider a surface. It's a plane surface we are taking, and a field line is this. It is entering and puncturing here and going this way. This is electric field line. So the normal drawn at the point of the puncture. Okay, so this is a normal drawn. Outward normal. Angle between the normal and field is theta. Right, so this should be theta. Remember, if they are perpendicular, for example, if E bar perpendicular to n cap, then the theta is going to be 0 degrees. If E bar parallel to n cap, then theta is going to be 90 degrees. Okay, you have listened correctly. Okay, and if they are parallel to each other, you should consider 90 degrees. If they are perpendicular to each other, you should consider 0 degrees. In the problem, in the given problem here, let me change the color. Yeah. So in the given problem, they have clearly mentioned in the description of the problem here, a square surface of side L. So square surface means their intention, the area is going to be L square. Okay, side L meters in the plane of the paper. Okay, in the plane of the paper is placed inside a uniform electric field E acting along the same plane, meaning the field also in the same plane. If the area and field are in the same plane, remember they are parallel to each other. If they are parallel to each other, angle is going to be 90 degrees. If they are 90 degrees, then according to the dot product rule, the dot product will become 0. So the flux will become 0 here. 99% of the students will consider option B as correct, but that is wrong. Understand? If they given normal, if the angle between the normal drawn to the surface and field is theta, then only option B is correct. The angle is not between the normal and electric field. The angle is between the tangent and the electric field. Okay, so it is 90 degrees actually. So this is how we have to deal with the fluxes. Okay. Next problem it is 3 point charges plus q minus 2q plus q are placed at points 0 comma x equal to 0, y equals to a, z equals to 0, like it is the 3 coordinates they mentioned, 0, a, 0, 0, 0, 0, a, 0, 0. Okay, and the magnitude and direction of the electric dipole moment vector of this charge assembly are. So it's very simple and straightforward. So remember, if you can draw the diagram, it will be very useful. Okay, these coordinates you have to locate in the coordinate system first of all. So consider this is your coordinate system, x axis, y axis and z axis. You know 0 comma 0 comma 0 is the origin, so this is 0 comma 0 comma 0. The second charge, which is minus 2q, is placed at the origin. Okay, first charge is placed at 0 a 0 on y axis at a distance of a meters. It has been placed, so plus q. And the third one, which is again positive, which is placed at a comma 0 comma 0, this third point. Okay, so on x axis it has been placed a comma 0 comma 0. Now for this charge assembly, they are asking you to find out the dipole moment vector. Okay, it's very simple. First of all, you should check out the monopole moment. Okay, monopole moment of the charge distribution. Monopole moment meaning the sum of the charges, algebraic sum of the charge. Okay, if this monopole moment is 0, then the dipole moment is independent of the origin. Okay, the dipole moment is independent of origin, right? So it is very clear, plus q and minus 2q, the monopole moment is 0. So dipole moment is independent of the origin, and for these problems the actual process is very lengthy. I am giving here itself a shortcut. I am giving, it's very simple. The dipole moment, the symbol is p bar, small p vector. It is summation over I runs from 1 to n qi into ri vector. Okay, where ri is the position of the ith charge, position vector of the ith charge, and qi is the charge of the ith charge. Okay, amount of charge of the ith charge. So here there are three charges. Okay, so if you apply this formula, 1 I equals to 1 2 3, first minus 2q is present. So anyway, first let me write here qi into ri. You should equate. If you expand this, you should take I value from 1, next 2, and then 3. Okay, so q1 into r1 vector plus Q2 into R2 vector plus Q3 into R3 vector should be equals to 0, right? So R1 vector is a position vector. Let us consider the first vector is at the origin, first charge is at the origin, second charge is at the, is on the x-axis, third one is on the y-axis. So Q1 is minus 2Q, R1 is 0 comma 0 I cap plus 0 j cap and then 0 k cap, right? Q2 is Q into, it is on the x-axis now, so Q A I cap plus 0 j cap 0 k cap. Q3 is on y-axis, it is positive, 0 I cap plus A j cap plus 0 k cap. So sum of these you have to add, okay? If you add, anyway this first term will be 0 and second is QA and third is also QA. So total if you take QA I cap plus QA j cap, but the magnitude only they are asking, so let me rip up this. Yeah. So the dipole moment vector P vector equals to QA I cap plus QA j cap. Then it is QA you can take common, it is I cap plus j cap. So magnitude if you find, it is very simple, I cap plus j cap magnitude is root 2, okay? So root 2 times QA, it is a magnitude of the dipole moment. What about the direction? Direction is like 45 degrees with the x-axis or y-axis also, okay? So this is how you have to find, and it is actually shortcut. You may feel the shortcut itself lengthy, okay, but actual process is even more lengthier than this, right? So don't feel burdened for this. It is actually a shortcut to solve the problem. But the shortcut is very simple. It is summation over Qi Ri, like summation over I runs from 1 to n Qi into Ri. Let us go to the next problem. A thin circulating ring of radius capital R is given a charge capital Q. The electric field at the center O of the ring due to the charge on the part AKB, this part of the ring is E, okay. Then the electric field at the center due to the charge on the ACDB of the ring is how much? It's very simple and straightforward. Remember, this charge distribution is symmetric. Symmetric distribution. Remember, at the point of symmetry, the electric field should be 0. Which field is net field, okay, not the individual field, okay. Net field should be 0. What is the point of symmetry? O is the point of symmetry. The point of symmetry is nothing but about which point the system, the charge is distributed symmetrically. That is what point of symmetry. Suppose there are 4 equal charges placed on the 4 corners of a square of side A, then center of the square will be the point of symmetry. Then at the center of the square, net field will become 0, right? And instead of square, here we are having a circle, right? So at the center of the circle or the ring, they given here ring, it is okay. So the net field should be 0, but due to AKB part, due to this part, the field is E, okay. Let us draw the diagram. Due to AKB part, the field is this way, E bar. Then definitely to cancel this, equal amount of field should be there in the opposite direction. Okay, due to the ACD part, this part, ACDB part, so that they will cancel each other, so that net field equals to 0. You should not calculate with the formula this problem, because if you calculate, you will get answer of course, but you will get after 5-10 minutes. Okay, this is a shortcut I am giving. I did not explain this problem in the actual way of explanation. I should not waste the time for this. Okay, so correct option is going to be option D. It is along the OK. So because of AKB the field is this way, because of ACDB the field will be this way, so that they will cancel each other. Because of the fact I said already, because the symmetry, point of symmetry, at the point of symmetry the net field should become 0. Example, one more example I can give you here. A circle a square you can consider of side A, and at the corners of this square you place 4 equal charges, and the center of the square the net field should be 0. Why I am talking about the center of the square only? Because the center of the square is the point of symmetry here. About this point the system is symmetric, so only at the center the net field should become 0. Similarly, you can have an equilateral triangle also, right? Equilateral triangle, and at each vertex you can place the you can place equal amount of charge, and at the center of the triangle the field should become 0, net field should be 0. And also sphere you can have, okay, then a uniformly charged sphere it is, and the center of the sphere should be again the net field 0. I hope you got it. So always at the point of symmetry the net field should become 0. This thing we can use as shortcut, right? So next question it is, a charge capital Q is situated at the corner of a cube. The electric flux passed through the 6 faces of the cube will be, okay, at the corner. Okay, they have mentioned clearly corner. So if you draw the diagram, it is based on the Gauss law. Very simple. Let this be the cube. You can even imagine this one. Yeah. So capital Q is situated at the corner. So corner is something which is inside the cube only you should consider. At this, you know that there will be 6 corners. So capital Q is corner, the capital Q is placed. Remember, while calculating the total flux or any flux you have to, I told you already in this class in the beginning, whenever the field line is perpendicular to the surface, flux will be there. Whenever it is parallel, no flux will be there. Okay, so capital Q is in contact with the 3 surfaces, 1, 2, 3. Okay, it is not in contact with the 3 more surfaces, because total 6 faces will be there. So the 3 surfaces which are in contact with the capital Q will not have flux. Understand? Only the 3 remaining will have the flux. So total flux is going to be Q by epsilon naught, right? Obviously Q by epsilon naught, it is option C is correct. There is no actually straightforward problem it is. Okay, if it is first option is correct, if they are asking if the charge is placed inside somewhere inside the cube, not at the corner, and the question is through one phase the field, the flux they are asking, means first option is correct. Okay, otherwise this problem can also be answered in another way. Let me think in another way, like, wait a minute, I will just rip off this. Let us consider the charge not inside, let us not consider the charge inside, okay, let us consider on outside here. So this is the situation, and to cover this charge we need 7 more cubes, okay. So already one cube was there, one cube already present here, so total 7 more cubes we require. So total flux will be shared by 8 cubes, okay, because 1 plus 7 is 8. So q by 8 epsilon naught can be correct. It depends on options actually. If the key given is q by 8 epsilon naught, this explanation is correct. If the key given is q by epsilon naught, then my first explanation is correct. I hope you got it, okay. And similar to this one, I can tell you one more. Suppose there is a cube and a capital Q charge is placed on the surface, like above the cube on one surface a capital Q is placed. Then how much flux is passing through the one cube? Then to cover this, to cover the capital Q charge which is placed above the surface, you need to have one more cube, like a cube over a cube. Okay. Now the two cubes can cover the charge completely. So the total flux q by epsilon naught, but it has been shared by two cubes. So through one cube, the flux is going to be q by 2 epsilon naught. I hope you got it. Similarly, this problem also. So let us discuss one more problem from the same potentials topic. And this is the problem based on the work energy theorem. The work done equals to difference in potential energy of the system, UF minus UI. So here F is the situation when the charge came to the capital D position, and I is a situation when it is starting at C. So it is starting from C and going along this curve or sphere and going to the D. So final minus initial potential energies, if you can calculate, and if you subtract them, you will get the answer for work done. And the final potential energy when it is here, remember there are two charges, minus q at A and plus q at A and minus q at B. So A to D, the distance is 3L because A to B is 2L, okay, and B to D is L. So final potential energy is going to be potential energy due to the A charge and potential energy due to the B charge. So K capital Q small q by 3L, this is due to A charge. Next minus K capital Q small q by L. Why I am taking here minus? Because the B charge is negative. So this is this total is final potential energy. Initially when the charge is here at the C location, of course it is subtracted here. Initial potential energy is K capital Q small q by L, because from A to C the distance L and C to B also same distance, minus K capital Q small q by L. Okay, and these two are cancel each other. So initial potential energy became 0, final potential energy is non-zero. So it is 1/3 minus 1. So minus 2/3 K capital Q small q by L. This is the work done. And this formula is applicable only when there is no change in kinetic energy. Okay, if there is no change in kinetic energy, then only this is correct. Work done by external force. Right, I hope you got it. And concept of equipotential surfaces is not applicable here because the C to D, the surface is not the equipotential surface. Right, next. It is based on the capacitors. The electrostatic force, the force is between two metal plates of an isolated parallel plate capacitor C having a charge capital Q and area capital A is. First of all, the force is equals to, remember, it is we can say charge into field, okay, charge into field. So force on each plate, if you consider the two plates, this is positive plate, negative plate. The plate, the field due to each plate will be, I'll write here, the E equals to sigma by 2 epsilon naught, right? Sigma by 2 epsilon naught. So you can write here E is sigma by 2 epsilon naught and Q into this way, I can say F equals to Q sigma by 2 epsilon naught. But sigma equals to Q by A, we can say Q square by 2 epsilon naught A. Then we can conclude the options here. Independent of the distance between the two plates, yes, of course. Linearly proportional to the distance between the two plates, no, this is not correct. Proportional to the square root of the distance between the two plates, no. Inversely proportional to the distance between the two plates, it is also no. It is because of the fact, due to the plates, uniformly charged plates, plus sigma minus sigma, the electric field is sigma by 2 epsilon naught, okay. So since the field is independent of the distance, so force also independent of the distance between the two plates. I hope you got it, right? The capacitance of parallel plate capacitor with air as medium is 6 microfarad. That is C equals to epsilon naught A by D, which is 6 micro, and this we should consider C naught. With an introduction of dielectric medium, the capacitance becomes 30 microfarad. So C, the capacitance with the dielectric medium is C, which is generally K times C naught. What is K here? Dielectric constant. The K times C naught is 30 microfarads. So C naught value 6. So we can say K equals to 30 by 6. It is 5. Right? Permittivity of the medium is how much? They are asking permittivity, that is epsilon. K is 5. Remember, K equals to epsilon R, relative permittivity and dielectric constant numerically equal. So 5. But epsilon R is epsilon by epsilon naught. From here we can say this is 5. Then epsilon is the permittivity of the medium. Epsilon equals to 5 times epsilon naught. Substituting epsilon naught value is 8.85 into 10 to the power of minus 12. So substituting, and you can select any one of the 4 options here. I hope you got it. It's very simple and straightforward. And next problem, what is effective capacitance between the points X and Y here? So these all the capacitors, see this, these capacitors are equal and these capacitors are equal. This is a balanced Wheatstone bridge with the capacitors. If you take the ratio of 6 and 6, it is 1. Ratio of 6 and 6 again 1. So ratio are equal. So this is a balanced Wheatstone bridge with capacitors. Balanced Wheatstone bridge, right? So whenever the bridge is balanced, you all know that the middle capacitor, if it can be resistor also, this you can ignore. Then the effective circuit diagram becomes this way. Okay, so 6 and 6, here 6 and 6. We all know that this is of course X and Y here. If capacitors are connected in series, they have to be added reciprocally. If they are connected in parallel, they have to be added directly. So 6 and 6 are in reciprocal, we have to add reciprocally to them. So the effective of these two will be 6 by 2, it will be 3. and similarly here also 6 by 2, so 3 and 3. So next step will be this is 3, this is also 3, but they are in parallel again. 3 plus 3 you have to take, then it will be 6 microfarad. I hope you got it. This one is very simple, it's a balanced Whitson-Beach condition. Thank you.